Yes, so just as you mentioned, I looked at which saprophilic beetles that are colonizing these habitat pies for stag beetles in southeastern Sweden. And before diving into the results, it's good to get some quick background, but some of it will be repetition. But it's always good to start with the veteran trees or old trees, which are these keystone structures in wooded pastures and forests due to unique ecological properties that they provide. And we've heard about some of them already, such as internal cavities, deep crevices. We've also have some changes in properties of both wood and bark as these trees age and increase in basal diameter. But there still remains variation along a trunk of an old tree, which allows the coexistence of competing species. We also have a large amount of dead wood that is buried in the soil in the form of roots, especially decomposing one when it comes to dying or dead trees. And due to some type of exploitation, we have a loss of habitat, or at least the distribution and size of old-growth deciduous forest in Europe, which is creating this loss of habitat that persists long enough for the larval development of certain saprophilic beetles. And this is the case for both species that are wound inhabiting both below and above ground. So these log pies or habitat pies for stag beetles are supposed to resemble roots or to some extent even stems of old trees. So we have the tree roots and the wood fragments that are embedded in litter that are used by a relatively large species community, you could say, of saprophilic beetles, but they are less studied than the ones above ground. So not much is known about them. But we have bark beetles of the genus Hylastes or weevils of the genus Hylobius that use these dead wood that is buried in the soil. And the same thing with some longhorn beetles like the weaver beetle or the tanner beetle. And we also have these guys, the stag beetle larvae, that are found in decomposing roots of quercus and other deciduous trees as well. So the aim of this study was to some extent look at if stag beetles colonized these habitat pies, which we know that they already did, but it was of interest to see if they would already colonize them because of the age. They were approximately 3 years old at the time of the survey. And also look at which other saprophilic beetles that are colonizing these habitat pies. And if there is a difference between the habitat pies that were of different age. So we had those that were part of Life Bridging the Gap, which were approximately 3 years old, but we also had those habitat pies that were approximately 10 years old. So we wanted to look at the difference between these two models, you could say, or versions. And also looked at some specific variables which could possibly affect the composition or richness or abundance inside of these habitat pies. Oh, memento is back. There's no time for exercise. And we've heard about a lot of the work that Life Bridging the Gap has done. I just chose to mention two of them that were quite relevant for, I guess you could say, the log pies or the habitat pies. And especially when it comes to reconnecting suitable habitats, which is the case with the wood mold boxes as well. So you have these log pies which would act as bridges in a fragmented landscape, where they would ease the dispersal of certain saprophilic beetles. And in total, there were 31 habitat pies distributed over southeastern Sweden. So we had 19 in Östergötland, 6 in Kalmar, and 6 in Blekinge. And I also looked at the different variables. I looked at the log size to see if the size of them that were used for the different sampling methods had an effect on these species composition and richness and abundance. I also looked at the soil, if it was sandy or clay soil, and what kind of effect that would have. So soil samples were taken approximately 2 meters away from the log pies because the soil was quite disturbed close to the log pies or the habitat pies. We also looked at the age. Well, we know beforehand doing the survey what kind of age these habitat pies had or were. But these were still taken into consideration when doing the different analysis later on. I also took measurements of the canopy openness, which just meant that taking a picture above the habitat pies to get a percentage of the openness, as well as the density of old oaks in the surroundings in different spatial scales of these habitat pies. So we have the red dots, which are habitat pies, and the grayish black dots, which are oaks and the density of them around these habitat pies. So we use three different sampling methods, and the first one is eclectotraps. Now, I learned during this survey that cutting through an oak log takes a lot of time, and it's quite tough. It's like cutting through rock almost. But yeah, usually I didn't have to cut through one of the logs. They were in appropriate size to fit into one of these black cloth bags, which had an attached bottle to them, which later on contained preservation fluid. So these were transported to the laboratory, where they were facing the window and received sunlight into the opening. So the beetles that would hatch inside of these logs would crawl out of the opening and down into the bottle with preservation fluid. And they were kept there throughout all summer. The second sampling method was sieve sampling, which meant that the surface of another log from the habitat pile was brushed, both on the surface and beneath the bark. And what was gathered from the sieve sampling was put inside a small black cloth bag, and this was then put inside of a Tullgren funnel. So we have these light bulbs which emit heat, and we have the sample inside of this funnel. So the beetles inside of the sample would crawl through the sample and fall through a steel mesh into these cups with preservation fluid. And the last sampling method was pitfall traps, which just meant that putting 2 glass jars into the soil relatively close to the log pies. And they were collected at 3 different occasions and were outside for approximately a month. And we had these roofs over them just to avoid having litter and other things getting inside of the pitfall trap. So the question is, did the habitat pies work? And the answer is, they worked very well. So when it came to stag beetles, both larvae and adults were observed at 13 out of 31 habitat pies. Larvae were observed during the survey at 5 habitat pies. It consisted of 14 individuals. And adults were caught with pitfall traps at 10 out of 31 habitat pies. Now, keep in mind that the surveys weren't focusing on stag beetles alone. So having these many was quite astonishing, because the larvae that were observed while one log was taken from the log pile. So that's just one small portion of the whole log pile. So you could assume that there's a lot more than the ones found during the survey. And the same thing can be said about the adults that were caught. They were caught with glass jars with a top diameter of 7.5 centimeters. I mean, that covers barely anything of the whole habitat pile. So that tells us that these are visited quite frequently and probably a lot by stag beetles. And there was a skewed sex distribution, so 15 were females and 1 was a male, which tells us that these are used as a suitable habitat, a place where they could lay their eggs. And a basic logistic regression was performed or conducted, which told us that the odds of recording a stag beetle were approximately 5 times higher when the habitat pies were on sandy soil rather than clay soil. So which other saprosilic beetles colonized the habitat pies? In total, we had 3,720 individuals of 220 species from these 31 habitat pies, which is quite amazing considering the time of these surveys. It was just from April to August on 31 habitat pies. And it was dominated by obligate saprosilic species, 139, which is quite surprising as well, especially when you use pitfall traps as a sampling method. You usually get a lot of the facultative ones. And 315 individuals of 18 species were red listed. And I just mentioned some of them, or the 5 most common red listed species, for those that could be interested in it. And when it came to the difference between the habitat pies of different age, the new ones, so those that were part of light BTG, approximately 3 years old at the time, were considerably more rich on unique species. They contained 46% that were unique, while 44% were shared between the old versions and the new versions. This could, however, be explained to some extent by the skewed distribution of the two models. So we had a lot more of the new log pies in this study. Another one could be that there are less initial colonizers when it comes to these log pies that are older or in a later decay stage, I guess. But it would still be most beneficial to have these habitat pies of different ages and different decay stages, because that would fit the widest community of saprosilic beetles that prefer these species at a different, or this tree host at different decay stages. Now, I don't know how much time I have left, probably not much too. Okay, so this was just quickly an ordination to see the effect of different variables on the species composition. The landscape and site factors used in this analysis, which were canopy openness, density of oak, soil type, and log volume, explained 21% of the variance, which is a decent amount. But this told us as well that there are other variables that are more appropriate or of a larger interest that explain this variation a lot more. But both soil type and density of larger old oaks were significant. And when it comes to richness and abundance of saprosilic beetles, habitat pies being on sandy soil was significant on both of these. A result which we didn't expect was that the density of large old oaks had a negative effect on the abundance. Now, the reason for this could be that the scales used, so we had different spatial scales, they were either inappropriate or we didn't include enough substrates. So, for example, we only looked at old oaks or large oaks, but perhaps we would have included other deciduous trees as well. It would also have been more interesting, I guess, because of this study object, to look at the amount of dead wood in different spatial scales rather than old oaks. In conclusion is that a considerable number of saprosilic beetles utilize these habitat pies. And it's most beneficial to have habitat pies of different age classes, and that they should be built on sandy soil, and that they are an important addition in nature conservation practices. Thank you for listening.